Hello and welcome to this section of the MATLAB tutor. Here we're going to begin to talk about vectors in MATLAB. And in truth, vectors and matrices really form the core of MATLAB. In fact, the name of MATLAB is Matrix Laboratory. The MAT means Matrix Lab. Vectors and matrices are basically the same thing, and so the core of what we're going to learn here and also with matrices, it really forms the core of how you use the program. So we need to crawl before we walk. Let's talk about how do we actually enter a vector. You know, in physics or in some sort of mechanics class, typically we learn about vectors in terms of x, y, and z at first, right? X component, y component, z component. So you might see something like, 3 in the x direction plus 2 in the y direction, plus 3 in the z direction. Now, of course, I can't type it on my keyboards, but this would be like 3 in the x hat direction. The little house on top means unit vector. 2 in the y direction and 3 in the z direction. Or in most physics classes, actually you use I, J, and K, right? So you have to kind of envision these little hats above the I, J, and K because I can't type them, but basically that's what they are. So 3 in the I direction, which is X, 2 in the J, which is Y, 3 in the Z, which is K. And we write that down when we do our math. But really, when you think about it, the only thing that really matters here are the numbers. I mean, if you always know that when you talk about vectors, you're talking about x, y, and z. If you know that you're always going to be talking about x, y, and z, then you really don't even need these labels. The only thing that really matters is going to be the 3 and the 2 and the 3 over here, right? So in MATLAB, we don't write vectors in terms of how I have it here. We don't say 3 in the I direction plus 2 in the J direction plus 3 in the K direction. We don't write it like that. In fact, if you just hit enter here, MATLAB isn't going to have any idea what you're talking about. It probably thinks that I is some variable and J is some variable and K is some variable. It doesn't know that this is a vector at all. So the way you define your vectors, if I were going to write this as a vector, if I were going to store this vector and name it x, right? Then what you need to do is open a bracket. All vectors are stored inside of brackets. So if I wanted to represent what I have here in terms of a vector, I would put 3 space 2 space 3, and then I would close the bracket off. This represents a vector in MATLAB. You put the spaces between so it separates the numbers, and MATLAB knows that the first number is separate from the second number is separate from the third number. And so if you hit enter, MATLAB is going to repeat back to you, okay, the variable x is now not just a number. That variable x is associated with it 3 numbers. And we just call those vectors in math, right? Now, if you go off and look here at the variable workspace over here, you'll see that x has not just one value, like usually if we do y is equal to 2 or something like that, then we have a value of a single value here. Now we don't have a single value associated with x. We have several values, 3, 2, 3. And if you scroll over for the single variable, 2 for y, it tells you the minimum and the maximum is 2. Here it tells you the minimum is 2 for this vector and the maximum is 3 because there's a range of values here and it's telling you the min and the max. So I guess what I'm trying to say is if you haven't ever done this kind of thing with a computer before, it may confuse you at first a little bit. But what we've basically done is associate with a variable more than one number. And it's this package we call a vector. Now, that is basically the essential part of it. If I want to overwrite y and create a new vector, then I could do 0 space 2 space 5 and close that off and hit enter. Then I'm going to have a vector y, which is basically going to be 0, 2, 5, which is what I have right here. And if I scroll over, then I have the min and the max for that. That's reflected right there. Now I want to take just a few minutes to talk to you philosophically a little bit about computers because when you're doing a lot of math in college classes, you're always talking about vectors in the context of XYZ, XYZ. That's kind of what we always use them for because it's so convenient. If we're trying to do the trajectory of a ball or something like that flying through the air, we might have an x component. In this case, the x component is 0, so maybe it's not traveling along x. And then we have a y component here, so it's traveling in the y direction with this speed or something. And then in the z direction, maybe this is how fast it's going up. towards the sky. So the three numbers represent something physically important. It's the speed in the x direction, the speed in the y direction, and the speed in the z direction. Usually we're using vectors to compute those quantities. Now you can use MATLAB for that purpose, no problem. We've assigned, if we were doing a problem that had a ball, then maybe one ball, the first ball, we're going to label it x, and we're going to put a vector together that represents its speed, x, y, and z. Maybe we have a separate ball, y, here's its speed in x, y, and z, right? So we can use MATLAB to store the vector values and do the math behind it, just like we do, your physics homework or your mechanics homework. We can use that no problem. Notice that we don't have to tell it that this is x and that direction, and that this is y direction, and that this is the z direction. That MATLAB doesn't really care about the labels. See, that's something you apply in your problem, something that makes sense in your physical problem. MATLAB only cares about the three numbers. It just knows that it has, element 1, element 2, and element 3 of a vector. The actual directions don't really matter so much because that's sort of defined in your problem. So I just wanted to point that out to you because a lot of people, when they start dealing with vectors in MATLAB, they start trying to assign directions and components and things like that and to kind of have it all labeled on the screen. But you don't really need to know that. For instance, if I'm going to dot these two things together, if I'm going to dot x and y together, which I'll do in future lessons, MATLAB doesn't really need to know that this is x, y, and z, and that this is x, y, and z, because all that really matters is element 1, element 2, element 3, and it knows what to do math-wise. All right. So what I'm leading up to here is if I want to create another vector, let's call it Jason. See, these vector names don't have to be single letters. It could be anything we want. I'll call it Jason. See, up to this point, I've been talking about x, y, z, for a vector. But you know what? In MATLAB, it doesn't have to be 3 dimensions, right? So you could have 2, 5, 4, 7, 9, or 8, 9, and 11. Or let's do 114. We'll close the bracket off. So this is a vector. We're going to call it a vector Jason. And when I hit enter, I have 1, 2, 3, 4, 5, 6, 7 elements to this. This is something you may not be that terribly familiar with in math, unless you're some computer programmers deal with this a lot. See, this is also called a vector. It just has more than three elements to it. You can have 100 elements to a vector or 1,000 elements to a vector. They're basically just a listing of numbers. So I guess what I'm trying to say is, in terms of math and science, when you learn physics, you're always taught that vectors represent these quantities in three-dimensional space. So they always have x, y, z. So a lot of students, they start using vectors thinking it's this thing that applies to x, y, z. Well, in the terms of MATLAB, you can certainly use them to deal with problems in x, y, z, like these vectors we've defined up here. But there's many cases when you just need to deal with a whole list of numbers at once, right? Maybe this is the population of, different hair color, in an auditorium full of people. That would mean that you'd have to have a listing of numbers. Maybe there's 2 redheads, 3 or 5 people with black hair, 4 people with orange hair, 7 people with yellow hair, 114 people with brown hair. Maybe you need to store that in terms of a vector because you're going to do some kind of statistical analysis on it. So you would store it in what we call a vector. So anytime in MATLAB help, when you read about vectors, it's probably a good exercise. Let's open this up right now. Let's type in vector. Let's see what pops up. We should get lots of things dealing with vectors because MATLAB is all about vectors, right? The position vector, all these things here. If you're reading anything about a vector, see, here's a vector defined up at the top here. If you're reading anything about a vector in help, it just means one of these listing of numbers. That's all it means. So Gibson, you could define it to be a vector, -5, 5.5, 3, 6, 9, -8.25, right? It's just a listing of numbers, right? So you can see that there's elements. Here's element 1, element 2, element 3. So I guess what I'm trying to say is start conditioning yourself. Stop thinking about vectors in terms of x and y and z. I mean, that's fine for your physics homework and your mechanics and things like that. That's okay. But in terms of MATLAB, you need to start thinking about, okay, this is a vector. It's a listing of numbers. This is element 1, element 2, element 3, element 4, element 5, element 6. And start to disassociate it a little bit from the rigid XYZ definition of what you think a vector is. Okay, so now we have several vectors already defined. I've got X, I've got Y, I've got Gibson, and I've got Jason here. So let me clear the screen real quick. And I want to show you something that's pretty important. Now, in this vector X, there's 3 elements. The first element is 3, the second element is 2, and the third element is 3. Let me put that back on the screen to show you. I'll just hit X, and I'll put those elements of that vector back on the screen. Maybe I've done some complicated calculation and I've arrived at an answer. This is the answer right here. This vector is the answer. But let's say that I only want, let's pretend this is X, Y, and Z like we were talking about before. Maybe I only want the Y component, the middle component. The way you retrieve that is you type in the vector name, parentheses, 2. When you see the vector name and put a parentheses with a number, what you're asking MATLAB to do is return the second element. Give me the second element of this vector. So it's going to go in there, fetch the 2, and return that to you. That is the second element. If I put parentheses 3 in there, it's going to return the third element of vector X. If I put parentheses 1 there, it's going to represent and return to me the first element of vector X. And the same thing applies to all of these vectors. If I clear the screen again, this is vector Jason that we stored before. But if I type in Jason and say, okay, I only want element 5. That's the only one I really care about. So it's going to go, here's element 1, 2, 3, 4, 5. There it is. It's going to spit it back at you. That's very convenient because you have to think about, I mean, you might say, why do you care about that? You can see the whole vector here. That's true. But maybe you're doing some calculation down the road where maybe, let's just put Jason back on the screen. Maybe you need to take element 2 of this vector, whatever it is, and multiply it by element, 5 or whatever. So instead of reading it off the screen and typing that calculation in manually, maybe you have a computer program that you write inside of MATLAB doing this. So maybe you could say Jason 2 multiplied by Jason 4. Right? So what this is saying is take the second element of this vector, which is this number, and multiply it by the fourth element of this vector, which is this number. So 7 times 5 is 35. So it's going to go grab those pieces of information from the vector and do the math that you have here. So you might have Jason 1, and you might divide by it Jason 6. So you might do some division or something like that, and it'll take the 2, because that's the first element, and 1, 2, 3, 4, 5, 6, and divide it by 9. So if you want to check that, 2 divided by 9 is 0.222. So that's all it's doing there. So 2 very important things that we've learned so far in this lesson. How do you input a vector? We've learned about how to do that, and how to extract individual elements from a vector, which you'll be using quite a bit in terms of using MATLAB and also writing MATLAB programs. One more thing I want to show you before we close this introductory lesson on vectors. So we've entered the vectors into the command window here, and every time we add a new one, right, I could say Earth, I could, like this, add a new vector. Whoop, gotta have an equal sign in there. Every time we add a new vector, it pops up over here automatically into the workspace area. And up until now, this workspace area has just been something I've showed you that just keeps track of all the current variables that you have and their values. And of course, we've talked a little bit about the fact that it tells you the min and the max. Well, you don't really need to use it too much, but I did want to point out to you that this is also a convenient way to edit the values of these variables if you need to. And let me show you what I mean. Let me type in a variable, A, and I'm just going to put a single number in there, 4. I'm going to put A is equal to 4. So here we have A is equal to 4. Now, if I double click on this, I'll double click it, and what happens is a variable editor window pops up. Notice it looks like a spreadsheet. It looks like something you might use in some kind of like office environment or something like this. And notice the value of 4 is the only element in here that has any numbers in it. That's because this variable just contains a single number. If for whatever reason I want to change the value of this variable, I can do it right here. I can change that value of the variable to 6. So I'll click off, it'll accept the 6, and then I can just close this window with the big X. It'll disappear, and notice the value of the variable has changed to 6, like this. Okay, so it gives you a convenient way to do that. Now for single values of variables, I mean, it doesn't really make any sense to edit the values over here. I mean, we can just reassign, the values over here in the command window. However, let's look at vector Gibson here. It's got lots of values here. Now I can pull this up and see, okay, here's element over here, the element 8.000. Maybe that's not quite right. If I want to change that for some reason, I can double click it and notice that all of the values that correspond to the elements of this vector are here. So maybe I want to change this element and I want to change it to, you know, -25 or something like that. I can accept that value, I can hit close, and notice that it's reflected here. So if I type in Gibson again, that value has changed. So this workspace over here, it tells you what currently is in memory as far as the variables. It also gives you the quick ability to make changes if you like. So this isn't something that you'll probably do too much, but it does have uses. I mean, for instance, what if you wanted to create a vector that was that had a lot of, you know, very small or very large numbers. In other words, 5.5 times 10 to the power of 5. Okay, that's a pretty big number. Let's do 6.25 times 10 to the power of, you know, 7. Maybe this one over here is, we'll just do something that we'll just highlight everything like that. And then maybe we'll do, you know, -2.5 times 10 to the -17th or something like this. Very small and very large numbers. Certainly we could go into the command window and we can type this stuff into our vector, but if you have lots and lots and lots of very small and big numbers, then it might be a lot to type into the command window. So you can just go and enter it here, hit X. So now let me clear the screen, and if I type in Gibson, then that vector is basically represented here. Now you might look at this and say, well, this vector, the elements of this vector doesn't really line up with what we typed in here, but when you really look at what MATLAB is doing is, it's because of the way the decimals are truncated. It doesn't quite look right. In fact, it's got 1 times 10 to the 7, so it's got a very large 1 with several zeros after it, multiplied by all these elements. If you change your format to something like long ENG, we've talked about those different format modifiers, for instance, then you can see that Gibson has all of the proper values in there. So this is -5, and then you have all of these other values. The last one here was -25 times 10 to the -18. So it's representing the same values that we basically typed in there. You know, you might use this workspace to create a very large vector, or in the future lessons we talk about matrices, you might use it to create a very large matrix. It's not something you're going to use too much. Most of the time when you define a vector, you'll just, you know, you'll just type a vector yo-yo and just put the values in there like that and then operate on them. So that's going to close it off for this section now. And notice here we type this yo-yo here. The values here have lots and lots of zeros here because we changed the format. If we type format short and then look at the value of yo-yo, then we have the 444 that we typed in there. So it's just a good example of how the format modifiers can change the way things look, but it's the same values. I hope you've gotten something out of this lesson. Vectors are super central to everything in MATLAB, so make sure you understand it, and then go on in and play with them, define them, and then if you need to extract a value, then we talked about that yo-yo, we can extract the second value and get the middle value here, which is the second element of that vector there. Follow me on to the next section where we'll talk about adding, subtracting vectors, and doing more complicated functions that involve vectors.